Alright, so today's lecture is going to be about conditional statements and branches. Now, this is the point where we start to get into the nitty-gritty of some actual coding. This is where things are going to start to get a little more complicated and involve some more thought and understanding of logic. Because conditional statements allow you to test two values against each other or test for conditions and affect the flow of code. So this is actually going to be changing how a program behaves based on variables or inputs. So this is starting to actually get into some real programming. So the first way to create a conditional statement or a branch is with an if statement. If, and this is what an if statement looks like. It's the word if, and then an open close parenthesis, and then two semicolons. Now, you note that there aren't any, or curly brackets. There aren't any semicolons here. No semicolons here because it's not a runnable statement, it's a test. You don't put semicolons at the ends of tests. You put them at the ends of statements. So, like this command here is a statement, so a semicolon gets put at the end. This is a conditional test, so no semicolon. Now, your conditional goes in the semicolons, or it goes between the parentheses. And then if it's true, whatever is in between the semicolon, or the curly brackets, is what gets run. So, let's create two integers, and we'll look at some of the conditional test statements that you can run. So, we're going to create two integers, int a and b. And I'm going to set a to be 1, and I'm going to set b to be 2. And again, this is going to involve some magic. So I'm going to take this statement out, and I'm going to put it in here. And I'm going to change this to say true. Now, this is where we get into understanding how the program actually runs, how it flows. The program is run in order, line by line. So it's going to run this first, then this, then this, then it's going to test the condition. If the condition is true, it's going to go into this statement and then come back out. If it's not true, it's just going to completely skip this and move down here. So at the bottom, I'm just going to change this to end of if, so that you can see how this program flows. So let's look at some of the test statements, and I'll put these in comments. The first one is not equal, or say that the first one is equal, which you run an equal or a test to see if two things are equal by doing a double equals. Now, when you do a single equals, that's the assignment operator. This means A is equal to 1. When you put two equal signs, it's a test. It means you're going to test if A is equal to B, or B is equal to A. Now, when I run this, you can see end of if. It never prints true. So it means it never went in here, which means A does not equal B. Now, I can say A doesn't have to be equal to a variable. I can make it equal to a constant. So I can say, does A equal 1? And if I run this again, you can see it's true because A does, in fact, equal 1. Now, I can say not equal, which is an exclamation point, and then an equal sign. So if A does not equal B, I can run this again, and you can see it says true, and then it hits the end of the if. So you can start to see how the program flows, how it runs, the orders in which steps are taken. Now, we'll talk about this later, but it is useful to know that CodeBlocks has in it a very nice debugger which will let you step through this line by line and let you see how the program flows, how it changes. But we'll get to that in a few minutes. For now, what I can do is say else. Now, this isn't just an if statement, it's an if-else statement. So if A does not equal B, it will print true. Else, which is the opposite of this, the opposite of A not equaling B is A equals B. I'm going to take this statement, cut it out, and put it here, and I'm going to make this false. Now, these two lines of codes don't actually do anything. Well, they do something. They don't do anything to alter the program in any significant way. All they are just outputs to say true or false. So they're not doing anything important. They're just signs to you to say that the if statement went here or it went here. Now, when you create this if statement, you can create an else statement as well. Now, this else statement is sort of like a catch-all. If this is not true, it will run whatever is in the else. It's never going to go in here. It's just going to jump straight into the else. So if I run this, you can see it says true. It never goes to the else statement. Because as soon as it runs this, sees that it is true, goes in here, and then jumps right back out. Never runs to the else. But if I make the test so that these two test to see if A and B are equal, you can see it just says false. It jumps straight into the else and then jumps straight back out. Never jumps into the if true. So that's how an if-else works. And you can have multiple layers of ifs and elses. You can change this to not just else, but else if. Else if A does not equal B. Now, this is exactly the same as just having the else, because it's the opposite of the if. So I run this, you'll see it says false. So it's exactly the same output. By saying else if, it lets you run multiple test conditions. So you can say if A, else if, or you can say if, else if, else if, else if, and then have all the way at the bottom an else. So you can have multiple different tests and multiple different outputs. So this is really adjusting how the program flow changes. Okay, so let's go back to the comparators, what let you test 2 bits of data. So you have equal, not equal. You have greater than or equal to, less than or equal to. So greater than is, these are all the math symbols. Less than, and, oops. What do I think? Oh, there's, and less than or equal to. So you can see that it's the same math symbols for greater than and less than, but when you want greater than or equal to or less than or equal to, you can have, or you can append the equal sign to it. And it really doesn't matter which side the equal sign's on, as long as it's the greater than equals and then the less than equals to denote which is which. So I can change this to say if A is less than B, and I'll get rid of this if statement down here. You can see it's true, A is less than B. Or if A is less than or equal to B. See, it's true. So you can create these statements to test various variables against each other variables, or variables against constants, or even constants against constants. As you'll see later on, you can test to see if 1 equals 1, which is a guaranteed true. So there are some times when you want to test if you want an absolute true. You always want it to run this statement. And again, that's going to depend on your situation. So that is the basics for conditionals and branching statements. So let's get a little more complicated into this. This is where some more heavy logic gets into it. I'm going to put in here another set of parentheses, And I'm going to say if A is less than B, which we know to be true. And then I'm going to put an exclamation point in front of it, and I'm going to run it. And you can see that this time the output is false. By putting the exclamation point in front of this statement, it inverts it. It makes it false. So it says, if not, A is less than B. So the exclamation point is always a not. So it inverts whatever it's next to. And again, this is where the order of operation thing comes in. This is where you should know how that works. Because having your parentheses and running things in the right order is what's going to change your program. You should always make sure that the behavior you want is the behavior you get. Now, there are other things you can do. So let's make a note of that. That's not. You can have and you can also have or. And is denoted as 2 ampersands, and or is denoted as 2 straight up and down lines. I don't know what those are actually called, but it's above the backslash. So I can say if A is less than B, or A is less than or equal to B, then I can change this to an and. Oh, that's not the right symbol. So you can see how this works. So you can have an incredibly long line of test statements in one if to test for multiple things. So if A equals 1 and B equals 2, you can see that's true. So this is where, again, order of operations and rigorously testing your programs to make sure what you get is what you wanted to have output is extremely important. And that's where the debugger comes into play. So actually, just before I go into the debugger, I want to talk a little bit about this. You can see that for equal and not equal and or, they are double the symbol. So it's 2 ampersands, 2 whatever these are, and 2 equal signs. It's because they have normal operators if you just put a single one in. We're not at that point yet, and I don't think we're going to talk about the operations that you can do with single straight up and down line or single ampersand. But single equal, remember, is the assignment operator. So remember that when you want to do a test statement, it's 2 equal signs, 2 ands, or 2 ors. It's not just a single one. Because, well, we can talk about that at the end with common errors. So, let's talk about the debugger. In code blocks, you have the ability to test line by line what the code is doing. And the way you do that is by setting a breakpoint. So, first thing you should do is make sure that you are set up into debug mode. And then right here, if I click on the line, if I click on next to 21, and I compile this, and then I hit this arrow, this is debug continue. Now when I hit this, the first thing it's going to do is it's going to run the program all the way up to the breakpoint and then stop. It's going to break. Now it's at this point that I can step through line by line to see what happens in the code. Now I can take any of these variables, right-click on them, and say watch, and it opens up a watch menu, and I can see the values that they have at this particular point in the program. And I can have multiple watches. I can even edit the values of the variables at any time I want to test various things. So that's all sorts of things you can do within the debugger. It's very interesting, and it's very, very useful. I can also right-click on the breakpoint and remove it, disable it, so you don't have to completely remove it. You can come back to it. I can edit the breakpoint. You can do counts. You can create an expression, so you can create your own test thing. So if A equals 1, it will stop here. So you can do all sorts of things with your breakpoints depending on how you want to test your code. So for now, let's just use this to step through the code. So there are all sorts of things up here, all sorts of buttons. First one's run to cursor, which will go to where this little, it will go to wherever you put your cursor. There's next line, which will let me step through the program line by line. Step into, which will let you step into functions. Step out will let you jump out of the function. And next instruction and step into instruction you probably don't need for this because this is just a C++ lesson and not an assembly tutorial. So for now, let's just step next line. So if I hit next line, you can see it jumps into the if statement. And if I find my terminal, there it is. And I hit next line. And if I find my terminal again, you can see it output true. And if I run this again, there we go. So it comes to a stop. You can see inferior process exited normally, so everything's good. So that's how that works. So you can use the debugger to step through line by line to various breakpoints and just test to make sure everything's working well. Now, the next thing you can do with if statements, this is where it gets more complex, well, even more complex than what we were doing, is you can nest if statements. So if I get rid of this and b equals 2, I can come within this if statement and put in another if statement. And I'll just put this in here. And I'll just create another output. There we go. And I'll run this, and you can see it says true and then almost true. So what's going on? It's coming into, well, actually, without even talking about it, let's just debug it. So what's going on? Well, we can see that A, in fact, equals 1, so it should go into this if statement, which it does. And if B equals 2, which it does, so it goes into that if statement. Now it comes out, and then it prints the almost true. So we didn't put an else there. So if we put an else there, if I stop this, put an else. And I back this up a bit and try this again. Alright, now we run it and we can see it goes into the true. It doesn't go into the almost true, jumps straight back out of the loop or of the if, and then goes to the end of the program. So you can nest ifs and if else's within ifs to create these massive branch statements, which, while incredibly useful, are kind of dangerous because it's very easy to get lost and forget what it is you're doing and how far in you are. It becomes very dangerous because you can lose where your curly brackets are, and you could end up putting the wrong statements in the wrong if statement. So it's all things you have to take care of, but also things that are very necessary when you write bigger and bigger programs. So you got to take with the good with the bad. You got to make your program work, and at the same time, you have to make it readable. You have to make it something that you can come back to and understand later down the road. So that is really it for conditional statements. I know that this was probably a little more complicated than some of the previous lectures. So before I end this, let's look at some of the common errors. The first thing you should always do is build every time you change a line before you debug something, because when you start debugging something, it doesn't use the latest version. You have to build it first to make sure it uses the latest version, because you could get some odd behavior if you don't make sure that the code is up to date. Now, if I get rid of the double statements and I just put in a single equals and I build it, so you can see right here it warns suggested parentheses around assignment used as truth value. It's warning me that I'm not using the comparison operator, I'm using an assignment operator. So it's not going to be comparing these two values. If I run this, it's always going to be true because it just assumes that this is true. Whenever you try to do an assignment operator and it works, it's going to return true, and then it's going to jump in because it's a true statement. So that's, again, something you should be careful of. Make sure you always use the right operator when you mean it. Obviously, missing brackets won't let you build, so always make sure you make sure that your brackets are lined up. Proper formatting is a good way to make sure that you don't do this. And as you can see here, the compiler is warning me that something down here is wrong, when in fact I have to move back up here. So always take what this says with a grain of salt, because what it thinks is right and what is actually right are sometimes two separate things. Now, as you can see here, I put the wrong curly bracket in. So just make sure you use the right curly brackets. A lot of times the auto-completion is going to do what it just did. It's going to put a curly bracket in. So just be careful of what is supposed to help you, and it might not actually help you. So these are all things to watch out for. And I think that is it for this lecture. I will see you all in the next video.